As we continue to work with exponents, we do have some formulas involving some exponential math. One of the formulas is what we call compounding interest. So we have a formula where A stands for the future amount or final amount, if you will. P stands for the original amount or the present value or initial, so original principal. Sometimes they'll use the word principal. So again, here they say A is the accumulated amount, or like I say, a lot of times it's the final amount. P is the principal or present value, if you will. The R represents the is the rate per year, which is an interest rate. So it's usually going to be a percent in the problem, but it's got to be expressed as a decimal. And then the N stands for the number of times it's being compounded in a year. So you may see a word like semi-annually. You may see the word quarterly, maybe monthly, or even daily. So semi-annually means twice a year. Quarterly means you compound the money 4 times a year. Monthly means you compound it 12 times a year. And daily means you compound it 365 days a year. So there's also a banker's rule that says 360, but I think our book uses 365 for that. So the more you compound it, it does add a little bit more to your principal. So a lot of times when it comes to savings accounts, you're compounding quarterly, but a lot of times credit cards are counted. If you have an outstanding balance on a credit card, there's more of a daily interest rate, so they can kind of really earn a lot more money from you, if you will, by cranking it up to 365 day as opposed to monthly or things like that. So anyway, let's just look at the question they have here. So a loan of $5,500 for 6 acres of woodland is compounded semi-annually at an annual rate of 9% for 3 years. Use the compound interest formula to find the compound amount and also the compound interest. So this is kind of way some of this math works, but again, you really to understand borrowing and saving money, you probably want to take some actual classes because those are two really important things uh, as far as understanding how quick it is to get into debt, but also allowing your money to make money is also a really interesting tool, like retirement plans and stuff like that. So in this formula, we're looking for the compound amount, which is going to be really our accumulated amount. So we don't know what A is. And a lot of times I'll go ahead and write down P. What else we have here? T, R, and N. So P is actually what we're borrowing in this case, the principal, the initial amount. That's the 5,500. The T is how long am I borrowing it for? And usually T's got to be in years. So it's usually something involving annual time in years. So it looked like we were doing this for 3 years. The interest rate is what is our what are we borrowing it at? So 9%, that's not horrible. These days, we prefer to keep our interest rate really under six, uh, closer to four or three or four if we can. But uh, so this is kind of what I would call a higher interest rate than usual. And then they also say we're compounding it semi-annually. So it does say twice a year. So again, we have a loan of $5,500 for 6 acres of woodland is compounded semi-annually at an annual rate of 9% for 3 years. And we want to find the compounded amount and the compound interest using our formula here. So our formula says A equals P times 1 plus R over N raised to the NT. So if we substitute in, that's going to be 5,500 is our principal times 1 plus then the rate has to be a decimal, so that 9%'s got to be 0.09. And n is the number of times per year, which is 2. And then we raise that to n times t. So 3 times 2 would actually just be 6. So I can do a little bit of that math. So I'm going to just use a calculator and type the formula in. So 5,500. And then we multiply that principal times our calculations, 1 plus the 0.09 divided by the 2. And then if we raise that to the 6th power, that'll give us our final amount. So our we end up borrowing 5,500, but we end up paying back $7,162.43. So the compound interest is how much interest did you have to pay. So if I subtract those two, so if I do the 7,162 and the 43 cents, if I subtracted what I borrowed to begin with, the 5,500, that'll tell us how much interest we had to pay back as well. So we ended up having to pay back $1,662.43. So keep in mind, on this example here, would have been wise to go ahead and save up the $5,500 so you didn't have to pay that kind of interest. So for this example, it would probably have been better to go ahead and try to save the 5,500 as opposed to paying an extra 16, almost $1,700 in interest. So that's the give and take of this. Most of us will borrow money, but the goal is to pay it back as quick as possible so you don't have to pay as much interest. So that's kind of the goal of all this. So it's not bad to borrow money, but pay it back as fast as possible.